Alright, what's up guys? In this video we're going to pick up with some calculus here. It's going to be another integration practice video. It's going to be example number 54 of our integration practice series. Okay, so we need to integrate dx over e to the x times the square root of 1 minus e to the 2x. So I would probably just start with a u substitution and see where that takes you. My selection for u here is e to the x because the derivative of e to the x is e to the x. So we'll do e to the x, and then we'll get e to the x dx after we differentiate it, and we'll get 1 over e to the x du is equal to dx if we actually end up solving for dx there. And so what happens is, I guess I'll do it over here. We end up getting the integral du over, well, it looks like we'll end up with u squared times the square root of 1 minus e to the 2x. So we still got that x flying around in there, but luckily for us we can use the substitution to convert it in terms of u. So since u was e to the x, and we need this e to the 2x in terms of u, what we can do is square both sides of our substitution to get x in terms of u. So that means that u squared is equal to e to the 2x, or you could say that e to the 2x is equal to u squared. Kind of switch it around to make it appear more clear. So now what the integral becomes is the integral du over u squared times the square root of 1 minus u squared. And that's what we need to integrate now. Now, we could probably do a trig substitution here. Notice that we've already done a substitution, and so we're using the variable u. Typically, with the trig substitutions, if we start off first, let's say we start out with the independent variable of x, and we would say that x would equal a tangent theta, a secant theta, a sine theta, depending on what the substitution is. But in this case, we're working with u. So what I'm going to do is modify the trig substitution formula a little bit. Instead of writing x is equal to, we'll write u is equal to, just so it's easier to follow, because obviously we're not doing everything in terms of x because we already did a substitution before. So if you look at the form that we have here, and even though we're going to use u instead of x, the process is the same. We're not changing the process at all. We're just changing kind of the independent variable. So if you notice here, we got the square root of, if you look at what we have the square root of a squared minus u squared. Okay. So this is clearly a sign substitution, because if we see that, we can do the substitution. U in this case is going to be equal to a sine theta. And if you look at what we have here, looks like our substitution is just going to be u is equal to sine theta. We'll need to find the derivative of that, which is cosine theta d theta. And we'll need to plug all that stuff in. So go down here to the integral here, and we'll have our cosine theta on top. Down here at the bottom, we'll have sine theta squared multiplied by the square root of 1 minus sine theta squared. Again, I'm not skipping steps. I don't skip steps in my videos. And that's going to be integrated with respect to theta. So we'll take care of the square root over here right quick. Hopefully you can easily see what's going to happen here. So we got the square root of 1 minus, and when I square it, I'll get the square root of 1 minus sine squared theta, which we know is the square root of cosine squared theta, which is cosine theta. So if we go back to the integral, what we got is, we got our cosine theta, which is on top. This sine theta here is at the bottom was being squared, so we have sine squared theta, and then we have a cosine theta here, and again it's going to be d theta. And as you can see here, the cosine thetas cancel out, d theta, which essentially leave us with 1 over sine squared theta, which we can convert into cosecant squared theta, because 1 over sine is cosecant. So that means that 1 over sine squared theta, we use a reciprocal identity, is cosecant squared theta. So that's what the integral will become now. So we got the integral of cosecant squared theta d theta. That's what the integral is now. And the antiderivative of cosecant squared theta is negative cotangent theta plus c. Okay, so recall that u was equal to a sine theta, or just sine theta. Okay. Again, it's going to be a little hard to follow because, again, we started with a u substitution up here. But, again, just try to keep track some sort of way of your substitutions here. I know it's a little bit confusing because we did a substitution up here for u, and then we're kind of using u as the kind of the branch off independent variable after we did the substitution. But the only reason I did that is because I don't want you guys to get lost if I were to replace that with an x. So again, I'll try to explain, and hopefully you won't run into this situation, but if you do, you're going to have to kind of come up with your own way of keeping track of what the substitutions that you've done. So no big deal in this video. I'm going to show you what the answer is, kind of explain everything. But if this happens, you have to come up with some sort of way to keep in mind what substitutions you did, but don't worry about it too much in here. So recall that u is equal to sine theta. And so if we wanted to solve for theta, for example, well, theta would just be arc sine of u over 1, which is just arc sine of u. So essentially, if we were to plug it in, go to another sheet. So essentially, if we were to plug that in, we'd end up with negative cotangent, and then you put arc sine back in there. I'm sorry, it's going to be arc sine of u plus c. That's if you plug it in there. Now recall that SOHCAHTOA, we know that so what we know is we know that sine theta is going to be opposite over hypotenuse, so it would be that, which means that sine theta will be u over 1. And we also know that cotangent is the reciprocal of the tangent. So if tangent is opposite over adjacent, then that means that cotangent is the reciprocal of that, which is adjacent over opposite. So if you notice here, what we're missing is the adjacent side. So recall that a squared plus b squared is equal to c squared. So we need the adjacent side. We don't know what that is right now, so we'll just plug it into the formula. So we'll get u squared plus b squared, or we need to solve for b because we need the adjacent side, is equal to 1 squared, which is a 1. And we need to solve for b here. So if we solve for b, we'll get b is equal to the square root of 1 minus u squared, which will essentially be the adjacent side. Is that the side that we were missing? Yeah, we're missing the adjacent side. Okay, so sometimes it doesn't hurt to have a triangle and draw it out. So we got the sides that we need, and you just basically have to plug those in because that's what we're going to need. So recall that, again, sine is going to be opposite over hypotenuse, which means that the opposite side of the triangle will just end up being u. The hypotenuse is going to be 1. And the adjacent side, which we were missing, is the square root of 1 minus u squared. When we actually solved for the adjacent side, because that's the side that we were missing. Okay, so that means that if we go to cotangent theta here, that means that cotangent theta is equal to the square root of 1 minus u squared all over u, because again cotangent theta is adjacent over opposite. Okay, so that's what we got in that issue. Okay, so now what we've done is we've taken care of all of the sides that we need. So now we just got to kind of go back and plug everything in. So we'll still have our negative on the outside here. And so what we'll have is square root of 1 minus u squared all over u. Put the negative in here. And then plus c. Now recall that the original substitution was u was equal to e to the x. So put that back in there. And if you do that, you end up with negative square root of 1 minus e to the x squared all over e to the x plus c. And you just got to kind of simplify it a little bit. And so we'll get down to our final answer at this point. So our final answer, we needed to integrate dx over e to the x times the square root of 1 minus e to the 2x. And our answer for this integral is going to be negative square root of 1 minus e to the 2x all over e to the x plus c. That would be your solution. Alright, so that one's a little involved, but again, I just kind of wanted to go through the whole process with you. And everybody has a different approach to math and how they go about solving problems. I don't believe there's one size fits all. I mean, if we can arrive at the same answer, I don't see the problem with doing it whatever way works best for you. So obviously you need to be doing everything correctly, but I don't see any issue with you doing things that is best for you. So everybody solves things differently. Maybe the way that I went about and solved it, maybe you could think of a better way, but again, these are just the ways that I approach my problems. And so yeah, so alright, so that's your answer. So you can check me on that, but I'm pretty sure that's going to be the correct answer for that integral. Alright, so I'll see you guys next time, and y'all take care.